Hello, I am Dr. Yayooo, owner of Yayooo Academy. I started at 2008 as online tutor for pharmacy license exams for FPGEE, NAPLEX, and PEBC. It is my pleasure to be with you today. Today, will be a continue of pharmacy license exams revision. I must thank Dr. Asma for her efforts in previous lectures at the beginning of this revision. And now I will be with you during rest of this course. Today review will be about insulin and insulin preparations. Are you ready? Let's start. Insulin. Insulin is synthesized as the prohormone proinsulin, an 86 amino acid single-chain polypeptide. Cleavage of proinsulin and cross-linking result in the 2-chain 51 peptide insulin molecule and a 31 amino acid residual C-peptide. Neither proinsulin nor C-peptide appears to have any physiologic actions. Insulin has important effects on almost every tissue of the body. When activated by the hormone, the insulin receptor, a transmembrane tyrosine kinase, phosphorylates itself and a variety of intracellular proteins when activated by the hormone. The major target organs for insulin action include 1. Liver. Insulin increases the storage of glucose as glycogen in the liver. This involves the insertion of additional GLUT2 glucose transport molecules in cell plasma membranes, increased synthesis of the enzymes pyruvate kinase, phosphofructokinase, and glucokinase, and suppression of several other enzymes. Insulin also decreases protein catabolism. 2. Skeletal muscle. Insulin stimulates glycogen synthesis and protein synthesis. Glucose transport into muscle cells is facilitated by insertion of GLUT4 transporters into cell plasma membranes. 3. Adipose tissue. Insulin facilitates triglyceride storage by activating plasma lipoprotein lipase, increasing glucose transport into cells via GLUT4 transporters, and reducing intracellular lipolysis. About insulin preparations. Human insulin is manufactured by bacterial recombinant DNA technology. The available forms provide 4 rates of onset and duration of effect that range from rapid-acting to long-acting. The goals of insulin therapy are to control both basal and postprandial, after a meal, glucose levels while minimizing the risk of hypoglycemia. Insulin formulations with different rates of onset and effect are often combined to achieve these goals. For rapid-acting, 3 insulin analogs, insulin lispro, insulin aspart, and insulin glulicine, have rapid onsets and early peaks of activity that permit control of postprandial glucose levels. The 3 rapid-acting insulins have small alterations in their primary amino acid sequences that speed their entry into the circulation without affecting their interaction with the insulin receptor. The rapid-acting insulins are injected immediately before a meal and are the preferred insulin for continuous subcutaneous infusion devices. They also can be used for emergency treatment of uncomplicated diabetic ketoacidosis. For short-acting, regular insulin is used intravenously in emergencies or administered subcutaneously in ordinary maintenance regimens, alone or mixed with intermediate or long-acting preparations. Before the development of rapid-acting insulins, it was the primary form of insulin used for controlling postprandial glucose concentrations, but it requires administration 1 hour or more before a meal. For intermediate-acting, neutral protamine hagadone insulin, NPH insulin, is a combination of regular insulin and protamine, a highly basic protein also used to reverse the action of unfractionated heparin, that exhibits a delayed onset and peak of action. NPH insulin is often combined with regular and rapid-acting insulins. But for long-acting, insulin glargine and insulin detamir are modified forms of human insulin that provide a peakless basal insulin level lasting more than 20 hours. Which helps control basal glucose levels without producing hypoglycemia. Now, it is the question time. This graph shows the serum insulin level that results from a 2-injection regimen given to a child with type 1 diabetes. Assume that both injections, indicated by arrows along the timeline, contain the same medications. What is the drug or drug combination that is most likely to generate the levels of insulin depicted in the figure? A 100% regular insulin, B 100% lispro insulin, C 70% NPH insulin plus 30% regular insulin, D 100% NPH insulin. E 100% insulin glargine. According to what we explained before, for insulin, answer will be choice C. In order to replicate the physiological situation with a baseline and mealtime peaks, one needs to combine insulin preparations with different durations of action. Finally, after we review for insulin today, I wish that you hit like and also subscribe for Yayooo Academy videos and YouTube channel. Thank you.